Scientists have waited a very long time for this news. They've been searching the fabric of space-time for what are known as gravity waves. These are basically ripples in the fabric of space-time that go right back to the moment of creation, the moment of the Big Bang. And now it seems they have discovered pretty firm evidence that these gravity waves do indeed exist. And here to explain the significance of this discovery is Professor of Astrophysics at Swinburne University, Karl Glazebrook. Welcome to Science Matters, Karl.
Thank you, Peter.
How did they actually discover these gravity waves?
So we have a telescope at the South Pole which measures microwaves, and we can see microwaves coming all the way to Earth from the Big Bang. And what this particular telescope did, much more sensitively than anyone before, is to measure the polarization of those microwaves, the angle of the light. For example, when you wear polarized sunglasses, you see light which is either coming up, down, or left, right. It's wave pattern, and there's two possible polarizations you can see, up and down, and left and right. And by taking a polarizing filter, you can measure the angle of the light. So as microwaves travel through space, if they encounter gravitational waves, they can imprint a particular pattern of polarization in those waves by changing their orientations.
All right. Okay. So you picked up these pretty sure signs of gravity waves, which go all the way back to the Big Bang. What is the significance of this development?
It's the first detection of gravity waves from the Big Bang. So the prediction is the Big Bang was a very, very big explosion in the early universe, but it's an irregular explosion, and all those irregularities would have been producing gravitational waves, a bit like rumbles in a thunderstorm.
Mm-hmm. And
prediction that they've always existed, but it's never been observed before. We know from Einstein predicted gravity waves back in 1917, and that was confirmed by experiments like the motion of Mercury and the motion of pulsars. They showed very clearly that gravity waves probably do exist. This is the first time we found cosmological gravitational radiation from the whole universe rumbling at once in gravitational radiation.
So does this provide a unique insight into the moment of creation, the moment of the Big Bang?
What it really tells us about is the very early stages of the Big Bang, a period that's called inflation, where the Big Bang grew very big very, very quickly. Basically the whole universe inflated by a huge factor in a very short period.
In fact, many times faster than the speed of light, which was what puzzles a lot of people, because they say, well, isn't light speed the ultimate speed limit? Yeah.
So in general relativity, the whole space-time can expand faster than light. It's only observers in the universe who can't move faster than light. So it's like the whole world expanding under your feet. That can happen, and doesn't violate any of the Einstein's laws.
So what are we expecting to learn from the gravity waves that have now been picked up?
So it gives us insight into this period of inflation. Inflation is powered by some force, some scalar field in the early universe, which causes that inflation, and the nature of that force is unknown. We think that inflation has to exist because of various other key observations in the universe. But now we have a direct connection back to that early time. We have a particular gravitational wave signature, which will then connect to theoretical models and actually try and make theoretical models of inflation that will actually constrain us.
So scientists are very excited about this, a very significant finding, and I guess there'll be a lot more said in coming weeks, months and years.
Yes, and in particular we expect the results to be either confirmed or denied by the Planck satellite in the next year.
Karl, thank you very much.
Thank you.